Right, let's finish the second half of this 2019, the non-calculator paper. So number 9. Here's the parabola. Obviously this is a maximum, it's upside down to the normal ones that we look at. It's a maximum turning point, right? We've been given the coordinates 420. Remember 420 means that you go along to 4, so that's number 4 there. And then it's 20 high, okay, so that's what the coordinates 420 obviously indicate. Let me just change the thickness of the pen, right, that's better. So write down the equation of the axis of symmetry. The axis of symmetry, if I was to draw on, it's not asking you to, but the axis of symmetry would be that line there, and dotted line I've put in. The equation of it is basically, what number does it go through on the x-axis? Well, the x-axis is the numbers across the bottom, and I've already mentioned it's going through the number 4, okay? And that's because the turning points has an x-coordinate of 4. So that's it, that's all you need to do for part E. Remember, look at how many marks it's worth. It does indicate how much working you're expected to do, just in case you're looking at that thinking, oh, it looks complicated. 1 mark is something quite obvious, okay? Right, part B, these two parts are only 1 mark each as well, so it should be something pretty straightforward. So it says the equation of the parabola is of this form. State the values of A and B, okay? Right, what I'll do with that equation, first of all, I'm going to rewrite it differently, okay? There's no need for you to do this. If you can see how to do this question, it's fine, okay? Normally, we have an equation with the x in the bracket like that, squared, plus the b at the end, okay? Now the reason I've put it like this is because usually the bit in the bracket is to do with the x value across the way, and the bit at the end is to do with the y value up and down the way, okay? You might have worked it out straight away. Yes, the value of b is simply 20, because the turning point you go up to 20, so b is 20. Okay, and remember this equation here that I've written out, rearranged slightly, is not necessary. Okay, the value of A, this number here, the negative at the front, remember that just indicates that it's an upside down graph. That's all that indicates, okay, with the negative at the front. The x plus A, the bit inside the bracket, is to do with the value across here. But you need to be very careful. A is not positive 4. Positive 4 is the value on the x-axis, but A is actually, and I'm hoping you're thinking it, A is actually negative 4. This equation would read x take away 4 inside the bracket. Number 10. So we've got a vector question here, P to R. P to R obviously is telling you how you go from P down to R. R to Q is telling you how to go from R up to Q. Okay, so we've to go from P to Q. So part A, how do you get from P to Q? Right, if I was to get from P to Q, I'm going to start here. Now we're not allowed to go the shortcut up to Q, okay? We need to go down this way and then up to that way to end at Q. So starting at P, we go to R. So we're going to go from P to R, and then we're going to go from R to Q. That's R down there, then R to Q. What you're basically doing is really just adding up your two vectors that you've been given. P to R was 6, negative 4. R to Q is negative 1, 8. We just add them. This bit here is not needed, okay? Add them together. 6 add negative 1 is 5, 6 take 1. Negative 4 add 8 is 4, 5, 4. Okay, that's your answer. Part B. Oh, don't forget there's a wee bit there, just in case we misread that. Not. See it? It says M is the midpoint of PR. Now if M is the midpoint of PR, that means P to M or M to R is half of P to R. Okay, so we have to find M to Q. So M to Q, I don't want to scribble on the diagram that I've just drawn up there, so I'm going to try and just do another wee sketch of it. Okay, diagrams are not needed for this. Okay, I'm just doing another wee diagram so that I don't scribble over the one I've done at the beginning. Right, so we have to show how to get from M to Q. So we're going to start at M, and we're going to go M to R, and then we're going to go R to Q. Right, we've got the vector R to Q. We were told at the beginning it's the negative 1, 8. We don't know what M to R is, but because M is the middle, the midpoint of PR, we know that M to R must be just a half of PR. Because M is the midpoint, Right? M is right bang in the middle of PR, so MTR is just a half of PTR. So let's work out the values, the components for MR. It's a half of PR, so it's a half of 6 negative 4. That's what PR was. A half of that is just 3 negative 2. So that's what MR is. So the actual question that we have to work out is MQ. So MQ is MTR. To get from M to Q, you go MTR, and then you go from R to Q. Right, MR, we've just worked it out. 3 negative 2. Add R to Q, we were given it at the beginning. Negative 1, 8. Oops. Add them together, 2, 6. Okay. Back to different colour pen. There we go. Number 11. Pam is designing a company logo. It's a regular pentagon. Pentagon, 5 sides, regular, all 5 sides the same length, okay? The vertices have been drawn, right, okay? So I've got like a pentagon. That will create the 5 isosceles triangles, 5 identical triangles. She then adds a design as shown to the diagram below, right? It's getting quite complicated. Right, okay. AF is the diameter. E to F is the diameter of the circle. A to F, right, which means A to O must be the radius. Calculate the size of angle OFB. OFB. Just to make sure you know which angle OFB is, it's O. It's that one there. O to F to B. So it's that angle in there we need to work out. But they've given us that picture at the beginning, so I'm pretty sure we're going to have to use this wee diagram up here at the top to help us. Okay? Right, so first of all, let's have a wee look at the diagram at the top. This angle in here, in fact, there's 5 angles, okay? They're all the same in the very centre. 5 angles, they're all the same. 360 divided by 5. And this is it's a non-calculator paper. 360 divided by 5. How many 5? That's a 0. How many 5s in 36? 5 7s are 35, 72. So each angle at the centre is 72. So that is 72. They're all 72. That's 72. Okay, they two are 72. Let's have a wee look now. Right, okay. These two are the same, okay? The radius and the radius, so these two are the same. We know that altogether it must make 360. Now, I'm going to take away those 272s. 360, take away the 272s. 272s are 144. Take it away. So it's 216 together for these 2 bits in the middle. Okay, I'll just look at one of the triangles on its own because they are really just looking for one. On its own, half a 216, I don't know why I'm doing a division sum. Half a 216, do I really need a big division sum, do I? Half a 216 would be 108, so that's 108 there in the middle. Can I fit it in? Just about. 108. My picture is not great, but this is the radius and that is also the radius. So if they're both the radius of the circle, that allows us to know that isosceles, these 2 angles are the same. 180, take away 108, leaves you with 72. And each of these together must add up to 72. 72 divided by 2. Each of them must be 36 then. So the angle that we're looking for is 36. Now there's really quite a few ways you could work out that one, but that's one version. Okay. Remember, as long as you set out working and show your answer, that's all we're really looking for. Okay. Show your working, obviously. Right. Number 12. Give it as a fraction, rationalise the denominator. Again, a couple of different ways you can do this. Okay. I'm going to do the most common method that people would use. Right, the common method is to get rid of the denominator that's the third, the square root on the bottom. You multiply by root 40 on the bottom. If we multiply by root 40 on the bottom, root 40 times root 40 is just 40. okay? But remember, you'd need to multiply the top by root 40 as well. So, as we said, root 40 times root 40 is just 40. At the top, root 2 times root 40, that is just root 80. Okay, we can't leave that as it is. We need to do a wee bit of simplifying here. It does say in its simplest form. Please do not do 80 over 40. You cannot simplify them. The 40 is a whole number at the bottom. The 80 is not a whole number. That's the square root of 80. Okay. However, what you can do is simplify the third. I'll do it just at the bottom here. Remember simplifying thirds. Two numbers that multiply to 80. And the first number must be a perfect square number. Let's think of two numbers that multiply to 80, and you think of your square numbers. 2 2s are 4, 3 3s are 9, 4 4's 16, 5 5's 25. These are all your square numbers. Right, which is the highest one that will go into 80? Because you need the highest one. The highest number there that will go into 80 is the 16. How many 16s make 80? 16 times 5 makes 80. So, root 16 is actually 4. So, root 80 is 4 root 5. So, at the top here, I'm going to write 4 root 5. At the bottom, it's still 40. Now, we can do a wee bit of simplifying. Divide the 40 and the 4, divide both by 4. If I divide them both by 4, it'll give me just a 1 root 5 at the top and a 10 at the bottom. And that's the answer. Okay. Number 13. Oops. Right, okay, we have a cost graph here. Right, okay, it's only 2 marks. Find the values. What does it say? Find the coordinates of A. It's got a turning point. Okay. There's a couple of different ways you can do this, to be honest. Right, let's see. See this 45 here? That changes the normal cost graph. Okay, let's think of what a normal cost graph actually looks like. The normal cost graph starts at the top, goes down and back up. Okay, and the turning point here would normally be 180. That's what a normal cost graph looks like. This plus 45 has basically taken this graph and shifted it 45 degrees in that direction, towards the negative direction of the number line. So that's why the graph looks a bit more like this. Okay, so the coordinates we're trying to find is that point there. Now, the minimum turning point used to happen at 180. As I said, it's shifted back 45. So the x value would be 180 take away 45. The x value must be 135. That's the x value. Okay, it says state the coordinates, so remember we're actually looking for the x and the y. So the x value is 135. The lowest value, the y value, we're looking for the y value. Because this is a 3 cost graph, that means the highest point must be 3 and its lowest point must be negative 3. So that means the turning point at the bottom, the lowest point, must be negative 3 here on the y value. That's its lowest point. Okay, so 135 is the x and negative 3 is the y. Number 14. So we have an equation to solve. There's a couple of different ways you can do this. Again, it doesn't matter how you do it. As long as you get the correct answer, then that's absolutely fine. Okay. What I would tend to do in a question like this is I would like to get rid of these fractions. Right? I really don't like the division by 2 and the division by 5, okay? It's making the equation very, very difficult to deal with. Right, a simple way of getting rid of this division by 2, I'm just going to wipe that out, I don't want it to block anything. An easy way to get rid of that division by 2 is multiply everything through by 2. Now if I multiply everything through by 2, I'm going to be left with x. I need to multiply the take away 1 by 2 as well. And I want to multiply this side by 2 as well. I'll just leave it as 2 times 3 minus x, over 5. That's an x. That's a bit tidier. I still get a division by 5. I'm going to multiply by 5 now. You might notice, or you might be saying, could I have just multiplied by 10 at the start? Of course you could have, okay? I've just done it step by step. Right, multiply everything through by 5. So I'm going to multiply all this by 5, so it's like 5x minus 10 essentially. If I multiply the right hand side by 5, the number 5 in the bottom is basically just going to disappear. Okay, so really what I've got is 5x minus 10 is equal to 2 times 6 minus 2x. Okay, let's tidy this up a wee bit. We've got x's on both sides. I don't want x's on both sides. I'm going to add the 2 x's on here. And 6, I'm going to move the 10 and add the 10 on the right hand side. So really I've got 7x is equal to 16. And if I know that 7x equals 16, don't be put off and assume, oh, that doesn't go in. Why is it not 7x equals 14? You do sometimes get a question where it does end up in a number that's a bit strained. 16 divided by 7. That's absolutely fine. We're not looking for anything simplified or anything. That's absolutely fine. Okay? Number 15. Right, okay, a ball is kicked off a rooftop. It says the height is given by this formula. So we've got this formula that says 12t minus 5t squared. H is the height. In part A, and what does t stand for? T is the time in seconds. Right, so it says calculate the height using the formula after 2 seconds. So after 2 seconds, that means basically t is 2. So we're just going to sub in the number 2. 12t, 12 2's, take away 5, 2 squareds. 24. Remember 5t squared means 5 times whatever t squared is. 2 squared is 4. So what we've got here is 24, take away 20, which is 4. 4 what? Calculate the height is in meters. 4 meters. Okay. Part B. Right, so we've got the graph h after t seconds, right? Okay, it's the same formula, right? Okay. Let me just get the formula back again. H equals 12t minus 5t squared. The height is equal to 12t minus, 5t squared. That's our formula we're using. Right, and h is the height and t is the time. So it says the sea is 17 metres below the cliff top. So that means the height must be, let me just go back. The height is the ball relative to the cliff top. So the height must be, what is the height? Negative 17. The height is negative 17. So I make it equal to negative 17. Okay? How many seconds? So basically we need to work out what t is here. Now, it looks a bit strange. It's got a t squared, it's got a t, it's got a number. This here is a quadratic equation. It's not our normal quadratic equation the way we like to have it looking. It looks a bit strange like that. Remember, this is a non-calculator paper. I'm going to tidy this up a wee bit because to solve a quadratic equation, the equation is not allowed to equal negative 17. It must equal 0. So I'm going to tidy all this up a wee bit. What I'm going to do, if you would do it differently, that's fine. I'm going to move the minus 17 across and make it a plus 17. Right? Now, I still don't like that equation. Some of you might have been able to just go straight ahead and done this at the start of this part, okay? I'm just going to tidy it up because remember we normally have our t squareds at the front, t in the middle, numbers at the end. It's looking a bit better. There's still something I don't like about that equation, and it's the fact that it's a negative 5t squared. I would much prefer if it was a positive 5t squared. I can actually change it to a positive 5t squared by multiplying the whole equation by negative 1. Right? Can change the sign of everything. It's as if you're moving it all over to the other side of the equal sign. Okay? Right, let's have a wee look. This looks a wee bit better, a bit more manageable. 5t, I'm going to try and factorise this because that is how you would solve a quadratic equation. 5t times t will give me the 5t squared. Now I'm looking for two numbers that multiply to negative 17. There really is only two numbers, right? We're looking for 1 times 17. It needs to multiply by negative 17 though. Let's see, negative 17, positive 1. That should, 5t times t is 5t squared, plus 5t minus 17, that's going to work. That'll work for us. And remember, to get our solutions, what do? You set the equations, or the factors even, equal to 0. 5t is 17. 0 add 17. 17 over 5. And in this one, t plus 1 equals 0. Move the plus 1 across. T is negative 1. That's our two solutions. So the question actually says, after how many seconds will the ball hit the sea? See this one here? Time negative 1 seconds? That doesn't make sense, okay? So basically the answer is 17 over 5 seconds.